First successes. It was only in 1857 that two French doctors, B. Paul and T.J.J. Vatel, clinically described the pathology, making the interesting affirmation, "You only pay when leaving." For the medical world, an embolism was completely anomalous. As long as the patient was compressed, he was completely well, and it was only when decompression occurred that the symptoms appeared. Then they disappeared as soon as the poor man was compressed again. Experimental observations in 1854 led Paul and Vatel to report on operative pressures, length of time at a particular pressure, speed of decompression, and the onset of symptoms. By discovering that recompression reduced the symptoms, the two scientists paved the way to solving the problems of the bends. More in-depth study on pressure variations was needed. It was the French physiologist Paul Bert who, in 1878, identified that nitrogen enters the tissues and blood in a solution, staying there as a dissolved gas as long as the pressure remains constant. He also established that if the pressure decreases quickly, nitrogen returns to its gaseous state before being transported through the body tissues and released outside the body. Baer proved that slow decompression was better, and he even pointed out the benefits of breathing normobaric oxygen. At that time, decompression was slow and continuous. In practice, it is as if we open a bottle of fizzy drink gradually so that the pressure is released slowly. Baer showed the maximum ascent rate to be about 1 meter a minute, 3 feet a minute, almost half that then in use by doctors in the British Navy. This reduction to the decompression rate greatly improved working conditions for most caisson workers and hard hat divers, and it also extended the operative depth limit to about 36 meters, 120 feet. But a mathematical model that simulated the absorption and elimination of nitrogen in the body tissues had to be created. In 1900, three German scholars, Heller, Mager, and von Schrotter, elaborated a model that simulated what happens in a human body during compression and decompression. However, this model was extremely elementary, considering the enormous number of variables that can influence the absorption and elimination of gas in the body. The three scientists applied Dalton's law to air in pressure, calculating that the partial pressure of nitrogen in air is equal to 79%. However, they did not take into account the different tissues in the human body, but considered it as just one homogeneous mass.